Have you ever looked up at the sky and wondered how we can make it rain? Welcome to our channel, where today we're exploring the fascinating world of cloud seeding. Cloud seeding is a remarkable technique used to modify weather patterns by introducing particles into clouds to stimulate precipitation. Cloud seeding is a weather modification technique where substances, such as silver iodide, potassium iodide, or dry ice are introduced into clouds to encourage precipitation. By providing additional particles for water droplets to condense around, cloud seeding aims to enhance rainfall or snowfall in specific areas. This process is often used in regions experiencing drought or to mitigate the impact of hailstorms on crops. However, its effectiveness can vary depending on factors such as cloud type, temperature, and humidity. History. Cloud seeding, the process of enhancing precipitation by dispersing substances into the air, has a fascinating history. It began in the early 20th century when a chemist named Vincent Schaefer discovered cloud seeding accidentally in 1946 while working at the General Electric Laboratory in New York. He found that by seeding clouds with dry ice, frozen carbon dioxide, he could induce precipitation. This discovery led to further research and experimentation. In the 1950s and 1960s, cloud seeding gained popularity, especially during the Cold War era when both the United States and the Soviet Union explored its potential for military purposes, such as modifying weather patterns for tactical advantages. During the Vietnam War, the United States military attempted to modify weather conditions to hinder the enemy's movement and support its own operations. Operation Popeye, conducted from 1967 to 1972, involved cloud seeding to extend the monsoon season in Southeast Asia, particularly over the Ho Chi Minh Trail. However, concerns about the environmental and ethical implications of weather modification grew, leading to international agreements such as the 1977 Environmental Modification Convention, (NMOD), which aimed to prohibit military weather modification. Scene script: how cloud seeding works. Identify target clouds. Cloud seeding begins by identifying suitable clouds that contain enough moisture but may not be producing precipitation efficiently. Introduce seeding agents. Seeding agents, such as silver iodide or potassium iodide, are dispersed into the target clouds using aircraft, drones, or ground-based generators. Nucleation. The seeding agents act as nuclei, around which water droplets in the cloud can condense or freeze, initiating the formation of ice crystals. Ice crystal growth. As more water droplets come into contact with the ice crystals, they freeze onto them and grow in size through a process called accretion. Output. Voiceover. After the ice crystals have grown in size, we move on to the final stage of the cloud seeding process, precipitation formation. The accumulation of water droplets onto the ice crystals continues until they become too heavy to remain suspended in the cloud. These enlarged ice crystals then start their descent towards the ground. Depending on the atmospheric conditions they encounter on their way down, these ice crystals may reach the ground in different forms. If the air below the cloud is relatively warm, the ice crystals will melt into raindrops. If it's colder, they might reach the ground as snowflakes. In some cases, they might even form hailstones. This precipitation, whether in the form of rain, snow, or hail, is the ultimate goal of cloud seeding. It's a fascinating process that, despite its complexity, ultimately serves a simple purpose: to bring water to places that need it. In the next scene, we'll take a look at the potential benefits and drawbacks of this technology. Stay tuned. Voiceover. Now that we have a good understanding of the cloud seeding process, let's talk about how the effectiveness of this method is monitored and evaluated. A variety of methods are used to track and assess the results of cloud seeding. One of the primary ways is through weather radar, which can detect the precipitation induced by the seeding process. By comparing the amount of precipitation before and after the cloud seeding, scientists can estimate the increase in rainfall due to the intervention. Ground-based observations are also crucial. For instance, observers may note changes in cloud patterns or other atmospheric conditions that could indicate the success of the seeding operation. Another important method is through direct precipitation measurements. This involves collecting and measuring the amount of rain or snow that actually falls to the ground in the area where the cloud seeding was conducted. Through these methods, scientists can evaluate whether cloud seeding has achieved its intended effect of increasing precipitation. However, it's important to note that these evaluations are complex, and the results can sometimes be ambiguous due to the many variables involved in weather patterns. In the next scene, we'll delve into the potential benefits and drawbacks of cloud seeding. This will help us understand why, despite its potential, cloud seeding is not a silver bullet solution for droughts or water scarcity. Stay tuned. Voiceover. As we venture further into our exploration of cloud seeding, it's important to note that this technique is not just a theoretical concept, but a reality that is being used in various parts of the world. Countries like the United States, China, Australia, the United Arab Emirates, Russia, Thailand, and Indonesia have all implemented cloud seeding programs for various purposes. In the United States, cloud seeding is primarily used to increase winter snowfall in regions that depend on snowmelt for their water supply. China, on the other hand, has one of the world's most extensive cloud seeding programs, often employing the technique to ensure clear skies for major events or to combat drought and boost agricultural output. The United Arab Emirates, a country with scarce rainfall, has been experimenting with cloud seeding to enhance water security. Similarly, Australia has used cloud seeding to alleviate drought conditions, while countries like Thailand and Indonesia use it to support their agriculture by increasing rainfall during dry seasons. Russia, known for its vast territory and diverse climate, has also used cloud seeding to manipulate weather patterns for various reasons, including to prevent rain from spoiling important state events. These global instances of cloud seeding underscore the technique's potential to address water-related challenges. However, it's also important to remember that cloud seeding is not without its controversies and challenges, which we will discuss in our next scene. Stay tuned. Voiceover. As we delve deeper into the world of cloud seeding, it's crucial to understand that while this technique holds great promise, it also comes with its own set of challenges and controversies. Let's take a closer look at the good and the bad effects of cloud seeding. Firstly, the good effects. Cloud seeding can augment precipitation in water-stressed regions, providing a lifeline in areas where water scarcity is a pressing issue. It also supports agriculture by providing additional water resources, helping crops flourish even in dry seasons. Moreover, cloud seeding can help mitigate drought conditions, proving to be a boon in arid regions. It even aids in wildfire prevention by increasing humidity and contributes to hydroelectric power generation by raising water levels in reservoirs. Now, let's turn our attention to the bad effects. Cloud seeding has the potential to disrupt natural precipitation patterns, impacting ecosystems and biodiversity. It raises concerns about water quality due to runoff of pollutants from the seeding agents. Indirect effects on climate and local weather patterns are also a concern, with long-term impacts still not fully understood. Ethical questions about interference with natural processes arise, as we are essentially playing God with the weather. Lastly, cloud seeding faces regulatory challenges and compliance issues with international agreements, adding a layer of complexity to its widespread adoption. Despite these challenges, cloud seeding continues to be a topic of interest for scientists and policymakers alike. As we delve deeper into its implications, we must strive to balance the benefits with the potential risks, always keeping in mind our responsibility to the environment and our planet. Stay tuned as we continue to explore this fascinating topic in the next scene.